Good morning, students. In the subject Manufacturing Technology 2, already we have completed 4 units. And today we are going to start the 5th unit, CNC machine tool and part programming. In the first unit, theory of metal cutting, we have discussed about the mechanism of metal cutting, tool life and the tool wear parameters. In the second unit, we have discussed about the constructional features of different types of lathes. In the third unit, we have discussed about the constructional features of different types of milling machines, the slaughter, paper and the planer, and also the gear formation and the gear generation processes. In the fourth unit, abrasive processes and broaching, we have discussed about the different types of grinding operations and finishing operations and also the broaching operations. Let us start the fifth unit, CNC machine tools and part programming. Introduction to NC machines. In all other 4 units, we have discussed about conventional manufacturing processes using lathes. Here we are going to introduce the computers to the manufacturing processes. NC is nothing but a numerical control. It is produced in late 60s, used electronic hardware based upon digital circuit technology. When we go for higher productivity, lower cost and precise engineering, we need to use the NC machines or CNC machines. A programmed part is loaded into the computer and then executed. And also it is defined as a programmable platform in which the manufacturing processes are controlled by numbers, alphabets and symbols. NC systems and its components. A traditional NC system consists of the following components. First one is a program of instructions, second one is tape punch, third one is a tape reader, fourth one is machine controller, and fifth one is NC machines. Let us start the components of NC machines. The first one is program of instructions. This is often called part program. The complete set of coded instructions responsible for executing an operation is called a part program. This program is a mixture of alphabetic codes, numerical data and special characters. Tape readers are used to transfer these instructions to a machine controller. The second one is tape punch. Usually it is a paper tape of 1 inch length. Paper mailer, aluminum mailer or plastics are used as a paper tape materials. Normally paper tapes are cheap and popular but cannot last long. It is treated to resist oil and water. Mailer tapes are expensive but durable. Presently, tapes are prepared by microcomputers by keying in the information from the manuscript. Once the entire program has been entered, it is checked and corrected if needed. And then the computer activates the tape punching unit to produce the tape. The third component is a tape reader. Usually tape punches are having holes on it. And the tape readers are used to read the whole pattern on the tape and converts the patterns to a corresponding electrical signals. Machine controller is the fourth component. It receives the electrical signal from the tape reader. It contains a decoder, encoder and an interpolator. Encoder or decoder receives the data and stores in memory locations. Memory locations are two types of part geometry data and process data. Interpolators are used to break down the curves into small individual increments. Machine controller also interfaces various machine units like drive motors, transducers and other control functions of the machines. The data of two types. The first one is a part geometry data, which contains tool motions, tool lengths, tool radius and tool compensations. The second one is process data, which contains feed rate, spindle speed, tool changes, cutting fluid application. The last component, NC machines, it responds to the electrical signals from the controller, fitted with the drive motors and other auxiliary functions of the machines. Transducers are fitted to feedback data on the positions of the slide wheel, for the RPM of the spindle, for the amount of cut on the job. Range from single spindle drilling machines to complex machines having multiple motions, tool changers, high capacity tool magazines and multi-axis control. Usually the NC systems are three types. The first one is point to point, the second one is straight cut and the third one is contouring system. Point-to-point systems also named as a positioning system. So it refers to operations that require fast movement to a point. Normally, point-to-point systems are simplest and the least expensive systems. A tool moves parallel to one axis or it may be moved at the same rate for both x and y axis simultaneously. NC systems using point-to-point systems are commonly employed in drilling, boring, and hole punching. Some PTP systems are equipped with milling capabilities also. And this diagram represents the point-to-point systems. Through PTP control, the drill spindle is positioned at a particular location, that is a starting point on the workpiece. The drilling operation is performed on the tool and the tool is moved to the next location, point 1, and point 2, and point 3. The process continues till all the operations are completed. Straight cut NC system. This is also known as a paraxial control system. In straight cut NC, the tool moves parallel to one of the major axes at a desired rate suitable for machining. The tool moves parallel to one axis or it may be moved at the same rate for both. Normally, straight cut NC machines are used for milling workpieces of rectangular configuration. No angular cuts on the workpiece is possible. It can perform point-to-point operations also. Contouring systems. It is also known as continuous path systems. The tool follows the desired shape since the commands are more descriptive than for the point-to-point systems. The movement of the tool is precisely controlled at all times in all planes. We can make angular cuts on the workpiece. It can read and feed instantaneous basis, commonly used in milling machines. The next topic is the tool positioning modes, also termed as NC related dimension. This is used to locate tool positions. Normally, the two types of positioning modes are used. The first one is absolute, the second one is incremental. Absolute system. While preparing the program, G90 code is used to represent or denote the absolute system. An absolute system is one in which all moving commands are referred to one reference point, which is the origin, and is called the 0 point. All position commands are given as absolute system from that 0 point. The 0 point may be either a floating or a fixed point. The 0 point may be defined as the point outside the workpiece or at a corner of the part. Absolute system may be subdivided into pure absolute and absolute programming. In pure absolute, both programmed dimensions and feedback signals are referred to a single point. Usually 90% of the point-to-point NC machines are using absolute programming. Incremental systems like G90, here the G91 code is used to denote the incremental system. An incremental system is one in which the reference point to the next instruction is the endpoint of the preceding operation. Each dimensional data is applied to the system as a distance increment measured from the preceding point. The incremental systems are not often used for controlling PTP machines tools. It is cheaper to build, but one of the major drawbacks of the incremental system is if one incremental movement is an error, all other subsequent movements become error. The example of absolute dimensioning and incremental dimensioning is given here. In absolute dimensioning, the coordinate values of each point is calculated from the origin. In incremental dimensioning, the coordinate values of each point is calculated from the preceding point. Without unit systems, we cannot identify the dimensions or in what unit. We are using two types of unit systems. The first one is inch system and the second one is metric systems. G70 code is used to denote the inch systems and G71 code is used to denote the metric systems. So far we have discussed about the components of the NC systems, types of NC systems and the unit systems used for making dimensions. Let us start the computer numerical control system. Introduction to CNCs. CNC is an NC system that utilizes stored program to perform basic numerical control functions. A mini or microcomputer based controller unit is used. The external appearance of CNC is similar to numerical control. The part programs are entered in similar manner. Punch tape readers are common for both NC and CNC machines. Evolution of CNC. In early stages, a machinist would produce superior quality but not at high volume that was required. As quantity increased, the quality of the product is decreased due to human factors. Electronic numerical integrator and computer was the first computer developed by the United States. This is the first digital computer that uses a vacuum tube technology. The programming involved setting of hundreds of switches and cables. In World War II, the manufacturers were in need to manufacture large amount of products for the war, and also in need for quantity as well as quality, and mass production also. These are all the factors influences the development of computer numerical control. Need for the development of CNC. There are numbers of problems in conventional NC machines which have motivated the machine tool builders to seek improvements in basic systems. Some of the problems are part programming mistakes, non-optimal speeds and feeds, punch tape wear and tear, least reliable tape readers, and less management information. And also to increase production, improve quality and accuracy of machined parts, and to stabilize manufacturing costs, and to speed up production and assembly operations, the CNCs are developed. Definitions of the various systems. First one is numerical control, a method of accurately controlling the operation of a machining tool by a series of coded instructions consisting of numbers, letters of the alphabet, and the symbols that the machine control unit can understand. MCU, machine control unit, decodes NC codes to drive and monitor servo motor movements. CNC, computer numerical control, computer provides machine codes to the machine control unit. Open loop systems, servo motor driven by pulses without feedback encoders. Closed loop systems, servo motor is driven by electrical pulses. An encoder provides feedback to verify machine movements. The stages of CNC machining process. In the first stage, the designer develops the CAD model. In the second stage, converting the CAD file to a CNC program. In the third stage, preparing the CNC machine. And the fourth stage is executing the machining operations based upon the CNC program. Advantages of CNC. In CNC, programs can be stored in computer memory. We can easily edit the programs. More complex parts could be manufactured. We can easily convert the units. Networking, file sharing to the other computers. Increased productivity after programming is completed. More reliable products can be manufactured. Single part and production runs can be programmed and machined with minimum effort and cost. Programs can readily be altered and rerun. Reduced inspection costs because it is more reliable. Once programming set up and verified, the equipment can be operated by a less skilled operator. And some of the disadvantages of CNC machines are initial cost of the CNC machine tools. Because CNC machine tools are always expensive, more expensive. Servicing of the equipment. Larger machines require more space. Personnel must be trained in the programming and operation of this equipment. CNC system elements. A typical CNC system consists of the following 6 elements. First one is part program. It is the complete set of coded instructions. Second is program input device. It's nothing but a keyboard. Machine control units, which is used to decode CNC programs to the drive systems. In drive systems, it is used to convert electrical signals into mechanical motions. Normally, hydraulic actuators, DC motors, or stepper motors are used as drive systems in CNC machines. And the machine tools and the feedback systems. A closed loop feedback system is used. Conventional milling machines normally used in lathes are given here. Advantages of CNC. In CNC, programs can be stored in computer memory. We can easily edit the programs. More complex parts could be manufactured. We can easily convert the Industry is most benefited by CNCs. Nowadays, most of the companies are using CNC machine tools in order to produce their products. Some of them are aerospace, machinery, electrical, fabrication, automotive, instrumentation, and mold making. Some of the sample products of CNC manufacturing is given in the next slides. Types of CNC machines. Based on motion types, CNC machines are divided into three types: point to point, straight cut, and continuous path. Based on control loops, open or closed loop motion control systems. Based on power supply, electrical, hydraulic, or pneumatic. Based on positioning systems, incremental or absolute positioning systems. Part programming. Part programming for MC comprises of the collection of all data required to produce the part. Part program is a complete set of coded instructions which describe the work which has to be done on a part in the form of required by a computer under the control of a numerical control computer program. The calculation of the tool path along which the machine operations will be performed. The machining data is as follows: machining sequence, classification of process, tool startup point, cutting depth, tool path, cutting and distance, spindle speed, feed rate, coolant, selection of cutting tools. Types of programming techniques. There are three types of programming techniques. The first one is manual part programming, the second one is computer assisted part programming, and the third one is manual data input. The first type, manual part programming. In manual part programming, the data required for machining a part is written in a standard format on a special manuscript. Usually the manuscript is a planning chart. Manuscript is typed with a flexowriter. Manual part programming is mainly used for point-to-point machines. Each set of instruction codes are called the NC block. A block is a complete line of information to the NC machines, and the block is composed of one word or an arrangement of words. And the blocks may vary in length, and the characters are used to form words. Program words are composed of two main parts: address and a number. Words are used to describe such important information as machine motions and dimensions in program. The block is marked by an end of block (EOB) character, which makes the data entry facility to start a new block. Second type, computer assisted part programming. In computer assisted part programming, much of the complex computational work needed in manual programming is performed by the computer processor. The programmer prepares the set of instructions in high-level computer language. The high-level computer language uses simple English words which can be converted to machine tool level program with the help of processors. Most of the programming language systems have been developed to perform computational work for the tool movements accurately, and the part programming becomes less time consuming and accurate. Apart from manual NC part programming, a number of NC programming languages are available for NC, CNC and DNC systems. These are APT, ADAPT, MiniAdapt, Compact 2. This is the computer aided basic program preparation. The third type is a manual data input. It is a procedure in which the part programmer directly keys in the program into the machine control unit of the machine tool. It helps the programmer to change and existing the program before the machining operations. Main limitations is that the data entry time is high, and thus this online system may be useful for small change in the main program. The most important NC programming language is APT, Automatic Programming of Tools. It is developed by a group of MIT. It has the largest vocabulary of the general processing languages, more than 300 words. The APT organization contains part definition, machining plan, and machining specification. Part definition. It defines geometric points and surfaces on a part which represent the size and shape of the part. Part definition involves the breaking the complex component shape into its primitive geometric elements. The geometric types in APT are point, line, circle, plane, vector, sphere, and Z-conic. The general format for geometric statement is given here. Machining plan. The three commands in APT for point-to-point machining are given here. For positioning the cutting tool with respect to the surface, a go command is used. For contouring machining, APT recognized three types of surfaces: drive surface against which the edge of the tool moves, part surface on which the end of the tool rides, check surface to which the current tool motion stops. Machining specification. This organization contains a post-processor statement and auxiliary statement. Post-processor uses an English-like statement to generate the data required to instruct the CNC machines. Auxiliary statements are the miscellaneous statements used to identify the part, tool, and tolerance. Before preparing the program, the programmer should know the different types of codes and their functions. The types of codes are given here: N code, G code, F code, S code, and T code. Sequence number or N code. It identifies the block and also increases sequentially through the program. G codes, preparatory functions. It informs the controller what types of motion or action is to be carried out. The mode of movement is indicated by the numerical value following the G address. In general, a G code is typed at the beginning of the block after N code. G codes may be modal or non-modal. For modal type, G code specification will remain in effect for all subsequent blocks unless replaced by another modal G code. For non-modal type, G code specification will only affect the block in which it contains. Single spindle NC drilling machine has three linear motion types: two horizontal table movements in X and Y direction, one tool movement in Z direction. For correct machining, it is very important that these motions are defined accurately. Some of the G codes and their functions are given here. G00 is used for rabbit positioning. G01 is used for linear interpolation. G02 is used for circular interpolation clockwise. G03 is used for circular interpolation counterclockwise. G04 is used for programmed dwell. And G90 is used for absolute programming. G91 is used for incremental programming mode. Feed rate or F code. It indicates the rate at which the spindle moves along a programming axis. In English system, the feed is expressed in inches per minute, and in the metric system, it is millimeters per minute. The feed rate is a modal code, and thus, unless a new F code replaces the old one, it remains in effect in all subsequent blocks. Example, F10 indicates the feed rate of 10 inch per minute. Spindle speed, S code. It specifies the spindle speed in RPM at which the spindle rotates. The numerical value up to 4-digit maximum is entered following the address S. The S code is modal and thus remains in effect for all subsequent blocks unless a new S code is entered. For example, S1500 denotes that MC machine spindle is set at 1500 RPM. M05 spindle off command, which is used to cancel the S code put before it. Tool code or T code. It is used to indicate the tool which is going to be used. Miscellaneous function or M code. It executes various NC machine functions not related to dimensional or axial movement. M codes are classified into two broad categories. The first category consists of those which execute with the start of motion described in a block. The second category consists of those which execute with the completion of motion described in a block. Examples of M codes are given here and their functions are also given. M00 is for program stop, M01 for optional program stop, M02 for end of program, M03 spindle on, M04 spindle on counterclockwise, M05 spindle stop, M08 coolant on, M09 coolant off, M30 program end or memory reset, M99 return from a subroutine. Subroutine or subprogram. A subprogram or subroutine is a separate program meant for performing a specific machine task. The subprogram becomes a powerful time-saving device and can be separately developed and debugged. The subprogram is identified by a letter P followed by a number ranging from 1 to 4 digits in the main program. The repetitive work of machining can be performed using a subprogram. Canned cycle. It is a preset sequence of events that is executed by issuing a single command. For example, G84 code will initiate tapping auto cycle. G81 to 89 are reserved for canned cycle. G80 is used to cancel the canned cycle. Do loop. In any part program, do loops are used to perform any machining operations repetitively. For example, in multiple turning, the same statements can be repeated a number of times using do loop. Common format of a block is given here. The block begins with a sequence number. After that, preparatory function, dimension, words, feed rate, spindle function, tool function, and miscellaneous functions. After the completion of the block, EOB mark will be given. Next topic is interpolations in CNC programming. It is the method of specifying the path to be generated for machining. There are two types of interpolations: linear interpolation and circular interpolation. Linear interpolation or G01 code. It is the movement of tool in straight line with any orientation. In part program, it is given by the G code G01. In this, the coordinate values of the destination point is given prefixed with the code G01. Data processing unit calculates the slope and trace the path values given. Circular interpolation or G02 or G03 codes. The movement of the tool along the circular path. The movement may be either clockwise or counterclockwise. G02 is used for clockwise movement, and for counterclockwise movement G03 is used. In addition, the arc center coordinates in increment mode or arc radius are given. Data processing unit determines the various points required for the interpolation. Dear students, if you have any doubts in this session, you can clarify your doubts through Google Classroom platform. And also the material for drive systems, machining centers, and motion control in NC machines, and sample programs will be posted in Google Classroom itself. Thank you.